Hello, in today's daily Leetcode challenge, the question is LFU cache, and in this question, we have to design and implement a data structure for a least frequently used cache. So, in this question, we have to implement two function, which is get, which will be coming with the parameter key, and a put, which will be coming with the two parameters key and value. So, this question should be made in average time complexity big of one. So, both these functions get and put should be implemented like that. So I made a presentation. In that presentation I have explained the questions, what is the expectations from the data structure that we are gonna make, and after that I have given the data structure that we will used for the implementation of this class LFU cache. And after that I have explained about the function which will I use in this question. And then after I will explain the code which I have used for this, and I will attach that code link into the description. The question is LFE cache. uh, it is a daily lead code challenge question for today. So in this question we have to implement a data structure which will be having an two important function that we have to implement, that is get and put. So in the get we will get a key, so we have to return the value which has been mapped to that key, and if it doesn't exist there I will return -1. And there is also another function that is put, which will come with two parameters key and value, and I will update the value of that key if it is present, and if it is not present we have to insert into the data structure, that is our LFQ cache. So if the data structure is full, right, so we have to like if the capacity is reached, so we have to remove the least frequently used. And suppose at the least frequently used, if I have more than one nodes, so what I have to do is I have to remove least recently used node. So in that I also have to implement least recently used, right? So let's talk about this example number one. So there are some queries from 1 to 10 which we are given with, and we have to perform this queries on the data structure that we have with a size of 3, right? So in the step number one, in the query number one, what we have to do is we have to put key value 1 with a value 10, right? So this will contain uh, my data structure will contain with a frequency of 1 the node of 1 comma 10, I can say. In next step, there's 2 comma 20 will be pushed in our data structure. In the third step, 3 comma 30 will be pushed in my data structure. In the fourth step, if it is of getting 2, so I will return the value 20 and increase the frequency of 2 comma 20 by 1, as it can be seen in my data structure. So let me take a pointer. So uh, uh, when this get to operation is called, that increase of frequency of 2 comma 20 will be there, and I will return 20, right? So next is get 3, so it will also increase the frequency of 3 comma 30 node. So it frequency will be becoming from 1 to 2, and I will return 30. Next query is get 1, so it will also return 10, which is the value which is being made for the key 1, and it will increase the frequency of 1 comma 10, that is the 2 now. Now as you can see that least frequent used is not 1 here, least frequent used is 2, but that is not our concern, we will look into it later. Next query is 4 comma 40. So here is a bit confusion in the data structure, that we already have reached our capacity. The capacity initially we have decided of our data structure is 3, but I am trying to put extra value, extra node into my data structure. So what it will do, it will remove the least frequently used, but here the least frequently used is 2, so it will try to remove a node from the least frequently used 2 here. So it will check that there are 3 nodes present at that frequency. So if there are 3 nodes are present at that frequency, so it will remove the least frequently used. So as you can see that the key values which are present there are 1, 3 or 2. So least frequently used is like I have just used 1, and then before I have used 3, then before I have used 2. So least recently used was 2. So I will remove 2 here and insert this 4 value with a frequency of 1, as it just currently been occurred in my data structure, right? Whenever I call for get 2 for the query number 8, it is get 2. So it will return -1 as it as of now doesn't exist in my cache because we have deleted just before. For get 3, it will return 3 and increase the frequency of 3,30. And for get 4, it will increase the frequency of 40 and increase the frequency of 4 and will return the value 40, right? So this is the complete intuition behind the example number 1 which I have taken here. So what I will use for this question, what is the data structure that is required to use and implement this LFU cache, right? So for this LFU cache, what I propose is that I will use two hash maps. First hash map will contain the frequency and the list, doubly linked list, which we have implemented, which we can implemented as a LRU cache, right? So if anyone want LRU like a separate video for LRU cache, please mention down that into below of this video. I will try to make that video, and by the end of this question you can understand the LRU case by yourself that how it works, right? So first map will be a frequency with a list, and this list will be a doubly linked list. So in doubly linked list, which we in the doubly linked list we have a next and as well as previous counter, and another counter will be of key and node. So this node will be this element of the map will be containing the address of the node where it is saved. So it is for easier access of the value. So if the class between two key values are there, I can easily update the values by accessing the address of the node there. So this is the hash map which will contain node as well as address, node map to its address. And third member function and third integer will be size. So what it will do is it will have the current size of the cache. So if the size is equal to capacity or extend the capacity value, that's a problem, right? So we have to delete some node for that. And another element which I will take is minimum frequency. It will store the minimum frequency currently in my data structure, right? So let's look into another example number 2, in which I will explain how I will use all this to uh, get to the implementation of LFU cache. So in the example number 2, the cache capacity is still 3, and these are the 10 query which we will have, right? And this is the data structure number 1, like this is the map number 1 in which I will have frequency mapped to my doubly linked list, and the key mapped to the address of the node which is at which the node is present, and also the size and capacity is there, and the frequency of the list minimum frequency which is been present in my cache, right? So query number 1 is to put 1 comma 0. So it's a simple query. So my size will increase by 1 and the minimum frequency will be 1 here, right? And my doubly linked list will be having a node which is 1 comma 10 and a address of x, right? And its frequency is 1 itself. So which will be also a matter of fact is that this frequency of the node should also coincide with the doubly linked list frequency where it is present, right? So this is present at the address x, so I will also update this key address map which is 1 map to the node address x. Next query is put 2 comma 20. Now whenever a new node is coming into the same frequency, I will push them from the front, because by that I am sure that the last element is the least recently used, right? This is the implementation of least recently used cache, right? So this can be understandable from here is that how we can implement LRU, right? and this address y will be kept here with the 2 comma y, right? Now next query is put 3 comma 30. So now our size will increase by 3 and capacity is increased by 3. So now you can see that my cache has a size of 3 which is the equal to capacity of 3. So now the minimum frequency is 1. So I will insert that 3 from the front of the doubly linked list. Now 1 comma 0 1 comma 10 is the least recently used, and I will insert that 3 comma z, which is the address at which this node is present, to my key comma address map. Next operation is put 4 comma 40. Now as we can see that this size will be increasing by the inserting this 4 comma 40 node, so this will become 4. So this is a problem. Now size is greater than capacity. So what I will do is I will get LFU, least frequently used. So least frequently used, as the minimum frequency is 1, so least frequently used is 1. Now in the least frequently used I can see there are 3 nodes. So in that I have to I have to delete least recently used from that doubly linked list. So least recently used in that doubly linked list is the last element which is connected to the last of this doubly linked list, right? So I will remove 1 comma 10 here and remove that 1 comma x from the key address map as well, key node map as well. So this will be removed, right? And still I have to put that 4 comma 40 into my map. So I will put that 4 comma 40 from the front of the doubly linked list with the frequency of 1, and also put that 4 comma w. So suppose this node is present at the address w, so I will update the w, right? So now next query is get 3. So for getting 3 I can see that for getting 3 it is present at the address z and its value is 30. Also its frequency will increase because it has least currently been used for getting it. So its frequency will become 2, right? And here all of this thing will be remaining same and we will return 30 here. Next query is get 2. So now frequency of 2 will also increase to 2, and it will be coming from the front because it is like a currently used node, and 3 is least recently used for frequency number 2, right? Next query is put 5 comma 50. Now 5 comma 50 is a like is it, it's an interesting question, is a static query, because here our capacity is already 3 here, right? So for inserting 5 comma 50 I have to remove least frequently used, right? So this least frequently used as of now is 4 comma 40. So I will remove this 4 comma 40 and insert 5 comma 50 with the address of b here, and it is also updated here in the key comma address map, right? Next query is put 5 comma 40. So here I have to update the value of the key value 5, but also the frequency of 5 comma 5 key value node, the node which have key value 5 will increase, right? So it will also come from 1 to 2, and it will come from the front side, and this 50 will be updated to 40 here, and the address remains the same. Next query is get 5. So what we will do is I will turn 40, but a frequency of 5 will also increase from 2 to 3, right? So this is that. And next query is get 3. For getting 3 I am getting uh, so one important thing that I have missed is that, so now here 5 comma 50 is inserted in my put 5 comma 50 inserted in my key. So now when I call put 5 comma 40, so least frequently used, least frequently frequency is 2 here. So my minimum frequency will also increase here, right? As you can see that least frequently used is 2 here, but as 1 is empty, therefore least frequency is 2 here, right? And the query number 10 what I have is get 3. So I will return 30 and increase the frequency of 3. So this is the example number 2 which I have explained here with the data structure which we will use, which I will use in my code for implementing get, get key, for implementing get function. So for from the key which is passed in the parameter I will find that key from the key node and extract the node position from the map, and then I will return the value which is present at the map. So if that key is not present in my key node, I will return -1. And also I will update that frequency of the node. So in the process of updating that frequency, what I will do, I have listed some step there. So from the nodes frequency, I will store the nodes frequency uh, in my class of the node, and then I will find the doubly linked list from the frequency list and call that remove node. What it will do is it will remove the list recently used into that LFU doubly linked list, right? So if that node frequency is least and the doubly linked list at that frequency is 0, then the minimum frequency will increase. So what I have mentioned is that this example here. So when I call 5 comma 40, right? So the list recently used become empty, right? And the frequency of the 5 comma 4 frequency of that number will increase to 2. So that will leave me with a empty frequency empty doubly linked list at the frequency number 1. So I will increase the minimum frequency by 1 here, right? So as the minimum frequency 1 doesn't contain any doubly linked list, so I will increase the minimum frequency there, right? So let's move on to the explanation. So if the node frequency, I will increase the node frequency by 1 and update that doubly linked list into my frequency list, right? So now for implementing put, if the capacity of my cache is 0, I will return 0. It's a edge case. So if the key is already present, I will find that node from the key node map, hash map, which I have there, and then I will update that value to the value which is been passed from this key comma value, and update the frequency list which is been, like, call the frequency list function. And then if it is not present and the size of the cache increases by the capacity, like it exceeds the capacity, I will do this steps. So I will find from minimum frequency I will find the doubly linked list, and I will remove the least recently used from that, and decrease the size of my LRU cache by 1, right? And I will put the minimum frequency as 1, because whenever the new element is arrived, the minimum frequency will be 1, because it will be pushed at the frequency 1 here there. And then I will make a frequency doubly linked list and insert that into the frequency list map, right? So this is the implementation for put. So let's move on to the code. I will add the code into the description, and from that you can find the implementation of the code which is being used, right? And if you have any doubt, you can comment down below in the video. So I will add this code link into the description. If you have any doubt in the code, and if you have any doubt in the comments which I have added here, so you can ask them into the comments below in this video, right? So here let's look into the node and doubly linked list structure which I have used here. So in the node I will have key value and frequency, and the doubly linked list node previous and next is also been used there. And this doubly linked list node will be having an constructor key comma value. So it will be storing those values, and frequency will be initialized by 1, right? In the doubly linked list I have add node and remove node. So add node will be done from the front and remove node will be done from the last, right? So in the LFU cache, as I have explained, I will have four things: size, minimum frequency, key node, and frequency list. And I will initialize all those values from the constructor. In the get I will do the same. I will find that node. I will find that node from the frequency key node map and return that value if it is present, and if it is not, I will return -1 and update the frequency of that node into the frequency list. That implementation has been written here, right? So I will also add the ppt into the comments there. You can also verify this edge case which I have written here, which is present in the 25 and 26. So I don't think there is like project PPT number been mentioned in the presentation, but you can find that from the description. In the put, I have implemented as same as what I have written there. Whenever the capacity is 0, I will return, and if that value, if that key is already present, I will update the value. If it is not present, I will check for the size exceed capacity, like size exceeds the capacity. And other than that, I will insert the new w linked list into my frequency list. So this is the complete implementation of LFU cache. Let's try to summarize this. Right, it got accepted in Java. I hope you like the video. Thank you for watching.